Hello, dear students. Today in this class, I would like to discuss data representation, the number system. Already we have discussed a few topics regarding this point. Any number system using a range of digits that represent a specific number. The most common numbering systems are decimal, binary, octal, and hexadecimal. These are the number systems in which we will represent our computer information inside it. Numbers are important to computers. Represent information precisely can be processed. This is the basic thing why we are representing data inside the computer to process it. Now, few examples are like to represent yes or no we are using 0 and 1, or to represent more than this we are using 0, 1, 2 and 3 to point out certain things. Now, positional number system means, as we are telling 1264, so these are the positions given to the digits. According to the positional values, we are finding out the values of the numbers. A computer can understand positional number system where there are only a few symbols called digits, and these symbols represent different values depending on the positions they occur in the numbers. Now, the value of each digit in the number can be determined using, and these are the few points in this the values of the numbers are represented. For example, the digit, the position of the digit in the number, the base of the number system. Because if we are telling, as an example, I have already told you that 1267, if I am telling you, so digits are same and always it is same, but the positional values just gives them the value according to their place values in the digits. Now, in the decimal number system, a number system that uses 10 digits 0 to 9 to represent numerical values, and in this we are representing it 10 to the power 0, then 10 to the power 1, 10 to the power 2, 10 to the power 3, and like this it is going on. In this decimal number system, we are representing it like according to their positional. You can see the decimal point here, and just left side the decimal point we will represent it in positive value 10 to the power 3, 2, 1, 0, like this. And after this decimal point we will represent 10 to the power minus 1, minus 2, minus 3, minus 4. So this is the LSD, and this is the most significant bit, this is least significant digit. The same thing in the binary number system. In the binary number system, two digits are there, 0 and 1, and we will represent it with the base 2, 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. And the same thing you can see here, 2 to the power 0, 2 to the power 1, 2 and 3. And after this decimal, minus 1, minus 2, minus 3, minus 4. The same thing we will represent in hexadecimal also. In this we will use 16, 16 to the power 0, then 1, then 2, then 3, and we will use 0 to 9 for digits, and we will use a b c d e f for 11, 10, 11, 12, 13 and 14 and 15. You can see here this is a digit, and in this decimal is in center. Left side we will use positive numbers, and right hand side we will use negative numbers. In the next octal number system, very obvious, we will use the base 8 in this, and the digits are 8 from 0 to 7. Now you can see in this left hand side from decimal 0 to up to 3, more than 3 it is going on in positive it is, and this side it is negative, it is going on. Now, how we will convert the number systems among each other, and every number system is convertible among each other. Now, few sentences are regarding this. In a digital system, 3 or 4 of these number systems may be used at the same time, so that an understanding of the system operation requires the ability to convert from one number system to another. Now we are going to discuss how to perform these conversions. First thing, students, you remember every number system can be converted in other number systems. First, I would like to discuss decimal number system, and I will discuss all the conversions, means decimal to binary, decimal to octal, decimal to hexa in this topic. First is decimal to binary. The process is same. You will take one decimal number, you will continuously divide the quotient, and you will note down the remainders. Then you will read it from down to top. As in this example you can see, decimal number is 43, divide it by 2, then 21 will come, and note down the remainder. Then again divide it by 2, then 10 will come, note down the remainder, and then read it from down to top. This will be the answer. In the second example you can see 200 is the example. Divide the 200 by 2, 100 will come. Again divide 100 by 2, 50 will come. If no remainder is there, then 0 you have to note down. Like this you will repeat the process and read it from down to top. Now convert decimal to octal. The same process you will follow. In that you was dividing the number with 2. In decimal to octal you will divide the number by 8 and you will repeat the process. Divide 266 by 8, 33 will come. Again divide 33 by 8, 4 will come, and finally 0 will come. Then you have to read the remainders from down to top. Now in the hexadecimal, the same process you will apply. In this, from 16 you will divide the number continuously. In the example downside you can see here, and in this example we have taken one number 423 and we have divided it by 16. Then 26 will come, again divided by 16, then 1 will come, and finally read the remainders from down to top. In the second example 214 divided by 16, again 13 will come, again divide it and read the remainder from down to top. Like this you will note down the values. Now for today's, in these three topics which we have discussed, decimal to binary, decimal to octal, and decimal to hexadecimal, you have some questions. These are 6 binary numbers which is given from your book. You have to convert these numbers in all the three. Means first you will convert these 6 in binary, then you will convert these 6 in octal, then you will convert these 6 in hexa. Thank you for today, and tomorrow in the next class I will discuss binary number system, and I will discuss all the three conversions, means binary to decimal, binary to octal, binary to hexadecimal. Thank you.